my name's Daniel, and this is Code to Bare Metal. I'm currently in my final semester of a computer science bachelor's, and I have some background in geoscience as well. So I initially found my love for computers, development, computing, etc., doing scientific modeling and data analytics, as well as doing some linear algebra, differential equations, mechanics, electricity, and magnetism. I really just love all things science. Um, I'm very intellectually curious, and I just find these things interesting. So over the course of the last year, I took an assembly language and computer architecture as well as a hardware design course. And alongside that, I spent a lot of my own time learning about compilers. And don't worry, we will get to the roadmap. I know a lot of you are here for that, but over the course of the next few months, year, however long, we're gonna take compilers step by step, talk about them, and hopefully learn something useful and get over that initial steep learning curve that exists. So, to qualify myself, I'm currently building my own statically typed language, and we'll talk about what that means and how you can make that design choice and why you might make that design choice. And to do that, I'm leveraging modern C++ and the LLVM, the low level virtual machine. So, I just want to say I'm a student and I'm no expert, but I've put a lot of time into this, and I think I'm qualified to give some real advice on how to start doing this because I recently had to get over the learning curve myself, and I'm still on the learning curve, and I'll be on it forever. That's the beautiful thing about our field, and not a lot of other fields are like this. Is there's so much information, so many things to learn that you get to learn for the rest of your life, and there's something kind of beautiful about that. So I hope that we can get you all to a place where you can really find this compiler journey to be rewarding. And yeah, so let's move on. So first, I just want to sort of do a high level overview of what the goals of this channel are. So this is really going to be a mishmash of a lot of things. So first and foremost, I am a lower level developer. I know C and C++ still high level languages, and if you don't agree with me, we're going to talk about why, and I'm going to convince you that they are. So we're going to be talking about low level concepts. We're not going to be talking about web development. We might talk about networks and WebSockets and things like that. Who knows? But yeah, you get the idea. So right now I'm focusing on compilers, and I think for the foreseeable future, as long as people want to see videos and learn more about it, we're going to spend a lot of time here and really take a deep dive into what's going on under the hood. On, when you write a piece of code, how is it actually running on your machine? So in addition, maybe we'll talk about computer architecture, embedded systems. I've done some FPGA design, breadboarding, low-level networking, so level 1, level 2, level 3. Who knows? It's really what you guys want, what I'm interested in at the time, and yeah, we'll just see where this goes. So these are just a few things. So I really aim to give you all a thorough understanding of how to go learn something and talk about my process and how I do things, but this is not a tutorial channel. When we talk about compilers, for example, I'm going to give you the resources, explain ideas, explain my thought process, explain the workflow, and, talk about design and maybe even a little bit of implementation for specific components. But I'm not going to walk you through step by step how to build your own compiler from scratch, because then it's not really your own, and you aren't forced to think about it in a deep way and really learn how those components are working. I just tell you what to do. So again, I think that will be more beneficial to you than anything, and I hope you think so too. So as a sort of short-term objective while I'm in school and applying for jobs, I want to get a video out to all of you at least once every 2 weeks, maybe more, maybe sometimes a little bit less if I have exams going on. We'll sort of play it by ear, but that's sort of the objective. And I just want to say I'd love to interact with you guys, so please leave comments with questions or things you want to learn about, and I'll try to make that happen. I will do my best to be as interactive as possible. So yeah, I want feedback from you all and questions. So today I'm going to talk about my journey to where I am now and how I got into the really awesome and niche world that is compilers and how you can do that yourself. I just want to acknowledge compilers are hard. They're really difficult to get into, and the learning curve is very, very steep, but that's okay. We're here to learn, so there's a lot of value in the learning. So first and foremost, the gratification when building a compiler or learning how these systems work is highly delayed. You don't get that instant, wow, okay, I did something really cool. So building a compiler front end alone, which we'll talk about that, what that means again later, but that requires a deep understanding of grammar theory, lexical analysis, parsing, code generation to an intermediate representation. And again, this is abstracting it because you're using an intermediate representation. So that's kind of, but that's the modern approach, and you learn a lot there, and it's more translatable to different computer architectures. So this is the way I've done it, and this is the way most people do it now, unless you're doing it for an academic exercise entirely. So once you get it to that intermediate representation, then you have a whole other can of worms to open, where you need to start thinking about how can I optimize this IR and condense repeated instructions into less instructions, and then IR to IR intermediate representation, IR to IR transformation. So going from LLVM IR to MLIR, that's a big task to undertake. And then beyond that, you have the entire compiler backend, where if you so desire, you can figure out how to get your IR to a specific target computer architecture. Now, lots of IR frameworks like the LLVM or MLIR provide a just-in-time compiler for you to translate to common architecture. So for example, I have an ARM machine, and LLVM provides a just-in-time compiler so that I don't have to build my own translation pipeline from LLVM IR to ARM, although I do plan to do that eventually because I think it would be really cool and interesting. And just to say, a just-in-time compiler is basically something that translates IR to machine code during execution time. So if you guys have used Java, what takes Java bytecode to your target architecture when the JVM is running would be a just-in-time compiler. But just a reminder, if you're so inclined, you can build your own. So yeah, this doesn't even scratch that surface of the full pipeline from whatever syntax you write to the bare metal if you decide to avoid IR. And that introduces a lot of extra problems. For example, you're writing for one target architecture, and operating systems introduce a lot of weird flags that need to show up in assembly code. So we tend to avoid that because intermediate representations can abstract that away for us, but we'll probably talk about that at some point, because that's something I want to explore, and I imagine some of you want to explore that as well, if not all of you. So getting back to why compilers are hard, staying invested can be an issue, because with something like, say, web dev, I can make something I can see and interact with in 5 minutes, and it's right there, great, gratified, you get the dopamine drip as you go, and that kind of maybe keeps you going. It doesn't keep me going. I took one foray into web development, and I wanted to get as far away from it as I could, but that's just me. In addition, with a compiler, you're generally not simplifying the process with lots of external libraries, dependencies, etc. It's just really you and the language. In this case, for mine, the one I'm writing right now, myself and C++. And yeah, I'm interacting with the LLVM APIs, but it's a very different process. And you really don't start to see results until you deeply understand the theory. So to really get started with this, you need to learn a lot, and before you even start coding or designing. So in addition, I know the documentation for the intermediate representation formats can be very cryptic and hard to understand. And I'll tell you in this series how you can set yourself up for success there. And I know the learning curve to results is very large, but when you start to build something, it's amazing, and you get a really deep and sort of methodical understanding of how the tools an everyday developer uses, and what they've been using for the past 50, 60 years, which are high-level abstract languages, C, C++, Java, so on and so forth. You could go on forever. There's so many programming languages, but you get to understand and build those tools, and that's pretty amazing. So just say they're hard, but they're worth it. They're really worth it. And I I really want to convey that message to you. I'm just going to start with my own personal journey. And I just want to say this is not the default way to go, but it worked for me. There really is no default way to go. So today it's just going to be very, very high level. And in the future, we're going to get into more of the nitty gritty and options that you have moving forward. But here's my process. So I got into programming languages just out of curiosity for the tools I was using every day. I mean, you use a programming language, and you're learning the principles of computer science. But do you ever think about how it works? Well, I started to, and it seems that all of you have as well. So I primarily worked in C, C++ with a little bit of Rust, Python, and Java. And I always wanted to know about that there be dragons territory of getting something as high level as human readable code to assembly and something an actual CPU can execute with, just electronics and binary numbers. So I did some research and thought a little bit more about the differences between compiled and interpreted languages, but I wanted to know more. That wasn't enough for me. So I did. I went and learned more. So I'm going to walk you through each step I took, which again isn't necessarily the correct path, and explain what I learned at each stage. And maybe not today, but another day, we'll talk about maybe what I would have done differently had I had the chance to do it all over again. There's a great book by Bob Nystrom, a game developer of all subfields of computer science, who just happened to be really interested in programming languages and how they worked, like all of us. So he talks a little bit about that journey, which is really interesting, and it resonated with me. And in addition, I just want to say this book is free online, and it's hundreds and hundreds of pages long, packed with valuable information. So that's another great positive. So he walks you through the process of designing a bytecode interpreter, it's sort of a transpiler too, but that's sort of a semantical argument that doesn't need to happen. And he does that twice, first in Java and then in C. The Java version focuses more on high-level abstraction. So what is a lexer? How does it work? Without thinking as much about how, at a low level, a lexer needs to be implemented, how you can optimize it, etc. Whereas in the C version, you need to think more about that memory management, data structure management, optimization, etc. I found the C version a lot more useful, but that's just me. They're both good. And the Java version is a good place to start. The one thing is, I wish I had spent more time with the book, but because I went through it really ravenously because I was enjoying myself so much. Nonetheless, it really scratched an itch for me that prompted me to want to go and learn more, and that's kind of how I ended up where I am now. And I think if you want a high-level overview, this is an unbelievable place to start. So the next component of my journey was sort of simultaneously to crafting interpreters, but I took an assembly language and computer architecture class where I learned a lot more about memory, register management, as well as all the instructions and instruction sets that exist for your CPU. Now, I'd worked with memory and things like that before, but this really drove the point home of, how pointers are working, etc. So at that point, I started to really think intently when writing code about how my memory was being managed, where things were working, how things were pointing to each other, how things were being accessed, where they were living, and also sort of as a natural extension of that, optimization. In addition, I took a hardware design course where we learned about integrated circuits, microcontrollers, breadboarding, some hardware descriptive language and FPGA design, as well as higher level concepts like latches, flip-flops, encoders, multiplexers, decoders, which all form the core of how your computer operates on a physical level, and I personally found that incredibly interesting. So I don't know exactly how one could go about just learning this stuff in the same way I did, but I don't think a course is explicitly necessary, and if you all would like, I can spend some time trying to curate resources that would give you a comparable understanding, or what I think would be a sufficient understanding of assembly language architecture and some hardware stuff to give you a better perspective on what's going on at that level, sort of below the compiler, but nonetheless. So this, coupled with Bob Nystrom's book, sort of prompted me to stumble upon the LLVM, and then at that point I was hooked. This was Chris Latner, the guy who made LLVM. This was his master's thesis, his work, which is just a mega colossal compiler infrastructure used across the board. It implements your favorite languages like Rust, Swift, many others. And I just wanted to know so badly how this piece of technology that I had never heard of before, but is so pervasive across programming languages, actually worked under the hood. This is the LLVM overview. As you see here, some of the documentation, just sort of clicked around the page a bit. And then I tried to delve into the docs a bit, and I soon realized how far in over my head I was. I knew what lexing and parsing were from the Bob Nystrom book, and, more than a cursory understanding, but I really needed to refine my theoretical understanding before I could dive into really trying to utilize the LLVM infrastructure. So to do that, I got Engineering a Compiler and the Dragon book, also known as Compilers, Principles, Techniques, and Tools, off of thrift books for like $10, and spent a good amount of time reading the relevant chapters to try my best to understand exactly what I was trying to do. In this case, learn about the recursive descent parsing technique in detail. And I think doing this is a very useful exercise, because if you understand it, you're going to not only build safer code, better code, you're going to build faster code, and you're going to work more efficiently. That's the bottom line. You're going to be more efficient, and your workflow is just going to be a lot smoother because you took the time to go learn. So once I felt a bit more confident, after I had gone and learned and refined my understanding, I worked through the LLVM Kaleidoscope implementation and added some of my own features. So they work you through a front end with C++, which I'm pretty comfortable with, from a custom syntax where they only use floating point numbers, and they take that to LLVM IR. Although it's relatively small, it's a great baseline and foundation to get a look at some of the LLVM APIs, get a feel for SSA and control flow, so long as you have a good grasp on the process of getting yourself to an appropriate data format before translation to IR, so lexing and parsing. They show you how to do it, but it's much more informative for you if you already have a deep understanding of lexical and grammatical analysis. So this was really just my jumping off point. And then once I was done, then I jumped into developing my own programming language, and that's what we're going to talk about next. This is the Pyroxene programming language. It's very much so a work in progress. I'm developing my own statically typed multi-paradigm programming language with a focus on the graph data structure for the purpose of state machine analysis. So pretty specific, but I'm going to have a lot of, the standard stuff, loops, conditionals, variables, or statically typed variables, and classes, and some other interesting features, which we'll talk about as we go through this series. So eventually I hope to build a direct pipeline to ARM assembly and maybe x86 later from the LLVM IR generate, but that's later for now. So it's still a work in progress, but the foundation I set for myself allowed me to jump into this confidently and build a code base I can be proud of that I know is safe, fast, and I know that I'm working efficiently because I learned the prerequisite theory effectively and comprehensively. So we're going to dive into this code base deeply in later videos, but this is where I'm at in my journey now. So all of you feel free to check it out. And I plan to make it open source in December. I just want to get a lot more done, get it to sort of a release ready state, and then I'd love to bring other developers into this. So that's something else we can talk about too. Just wrapping up here, I hope this was informative for all of you. Next week, or in 2 weeks, pardon me, I'm planning on talking about lexical analysis, or maybe the difference between interpreted and compiled languages, as those are both really important. We're going to do both of those at some point. It just depends on ordering and based on what you all want. If you want something else, comment it, and if there's enough push for it, we'll do that instead first. I just want to remind you, this is a worthwhile journey that is incredibly rewarding and informative, and it will allow you to build incredible pieces of software. Even if you don't end up as a compiler engineer, going through this process will make you an immeasurably better developer, as it applies so many ideas into one piece of software. I hope you all enjoyed and that you stick around for the next one. Please like, comment, and subscribe, and leave any feedback about format, questions, or suggestions. Thank you again.